Hey students, this is Mrs. Tran-bloom. I am excited to be recording 2.9 with you guys, graphing any function strategies. So this is where we are putting every single thing that you guys have already studied together. Ready? When graphing an unknown function, ask yourself the following questions to begin. What type of function is this? Okay, is it in standard form? Is it in HK form, which is your vertex form? Is it in the intercept form, which is the factor form? What is the highest exponent? Exponent, students, of an equation is sometimes called a degree. So if you hear us saying, what is the degree of the function? That is the highest exponent of the function. Remember, the turning points at most would be one less than the highest exponent. Okay, so how many turning points would we have? Are there any values likely to be excluded from the domain? Normally, that would happen if you guys have a variable in the denominator. Now, if we have parentheses, plug in a value to make the expression inside zero. This is the same thing as to find the X-intercept, okay? And then from there, make a table of value to get some ordered pairs. A good table of values includes some zeros, some negative numbers, and some positive. So let's go to examples 1 to 5. Sketch the graph of the function given. So this one says f of x equals x to the 4th minus 3x to the 3rd plus 2. Now, out of these three terms, this is the highest exponent of this equation. So students, this function has a degree of 4. Now let's also find the a value. The a value is always in the front, right, of the highest power term. So that a value, students, is going to be 1. Well, a degree of 4, so this is an even degree, a degree of 4 and a being a positive 1, we do want to talk about the end behavior. So we will have an idea of how this will look. As x get to be really, really, really big, like towards positive infinity, because it is a degree of 4 and a is positive, we know as x goes to the right, y goes up. Okay, so y goes towards infinity. Now, what happened when x goes towards negative infinity? For an even degree and a being positive, y is also going to go up as well. So we know that our end behavior are going to go upward. Well, the easiest thing for us to find right now would be the y-intercept. Y-intercept, students, is when x equals to 0. Now, if x equals to 0, this term disappears. This is gone. So we are going to have 0, 2. So currently, we have 1 dot, 0, 2. Well, that's not enough, students, for us to be sketching this out. And so what we want to do next is see if this is factorable, and it is not factorable. Okay, so this is not factorable. So our next task is normally we want to make a table to see if you can plug in some values. Okay, we are going to start with -1. So -1 to the 4th minus 3 times -1 to the 3rd plus 2. -1 to the 4th, that's going to be 1. -1 to the 3rd, that's -1 times -3 is now positive 3 plus 2. So this is going to give us 6. And now we're going to go -1 up 6. Okay, I'm going to go one more to the left to see what's really going to happen. So -2 to the 4th minus 3 times -2 to the 3rd, drop down the 2. -2 to the 4th, student, is 16. -2 to the 3rd is -8. -8, students, times 3 in the front, so that's a positive 24. Add 2. Well, 16 plus 24, that's going to be 40. 40 plus 2 is 42. Well, that's a really large y value. So technically, let's pretend that 42 is all the way up here, okay? I don't need any more negative x to use. Now let's try to see if you can use some positive y values. Some positive x value to see what the y value will come out. So 1 to the 4th minus 3 times 1 to the 3rd plus 2. Well, 1 to the 4th is 1 minus 3 is now -2. -2 plus 2 is going to be 0. So this is 0. So at 1, x is 0. We know that it should look like a parabola. So if we connect these, let me just go connect this left side. We know it has to go up, right? So right now that's not going up. So I'm gonna go pick another positive value to see what the behavior is. So 2 to the 4th minus 3 times 2 to the 3rd plus 2. So 2 to the 4th is 16. 2 to the 3rd is 8. 8 minus 3 is going to give us negative 24 plus 2. 16 minus 24, students, that's going to give us a negative 8. And negative 8 plus 2, that's going to give us a negative 6. So at positive 2, go down to negative 6. So I'm going to have to make this really pretty in a little bit. Okay, it's still not going upward. So let's try another value, which is 3. Okay, so plug it in. Why don't you plug it in and then give me the answer? So 3 to the 4th minus 3 to the 3rd, minus 3 times 3 to the 3rd plus 2. What do you end up getting? Okay, hopefully you guys got 2. So when x is 3, ooh, yeah, it's curving back up. That looks awesome, right? So as you can see, this is, I'm gonna make it pretty. It's curving back up. I'm gonna go do 4 next. Why don't you guys plug 4 into the equation and check out what you get? Okay, so I hope you guys have the same thing, which is 66. Well, that's a really big y value that I don't have room for. So I know that looks like it's curving back up, which I'm gonna erase this and make sure I try to make this slightly prettier. Well, you know what I did earlier? It was negative 6 and I plotted negative 5. So let's just plot right there. Okay, so let's try to see if we can make this super pretty. Are you ready? Connect those, this roundabout. And we know that was like supposed to hit 66, but that's, all right. So this, by connecting those dots, that's what we have. Now, if we want to look at the turning point, we know the degree is 4, students. So this function should have at least 3 TPs, turning points, okay? Well, it does have 1, and that's okay. 1, it's okay to have, because when we say at least 3 turning points, technically we can have 3, we can have 2, we can have 1, and technically we don't have none, because a cubic function doesn't have a turning point sometimes, okay? Example 2, y equals absolute value of x minus 7. So as you can see, this is an absolute value function. Let's identify a, it's 1. Well, that's a positive a, so we know it opens up. Now, if you know that you can find the vertex right away, h is going to be 7, k is going to be 0. So students, your vertex is going to be 7, 0. We can plot that immediately. Then if you guys remember that we can also find the slope, right? The slope is going to be plus or minus your a value, which is 1. And the axis of symmetry, remember, it's a line that runs right through the vertex, and that's going to be x equals the h value, which is 7. So here's the axis of symmetry, and if we can use the slope to graph it out, do that. Remember, the slope is plus and minus 1, so we can go up 1, right 1, up 1, right 1, up 1, right 1, or we can go down 1, up 1, left 1, because it's a negative. Up 1, left 1, up 1, left 1. If you guys remember, I normally make enough dots to make sure our lines are straight and use a straight edge. Okay, so here's my ruler, connect those dots. So here's your V. This is your absolute value function, which is a V. Now, you guys also study transformation. So for transformation, students, we can definitely do another method. We can start out with the parent function, which is absolute value of x. And remember, we can always pick -2, -1, 0, 1, and 2. Absolute value of -2 is 2. Absolute value of -1 is 1, 0, 1, and 2. Since we only have one transformation, which is the h value being 7, that goes to the right by 7. Y value is not changing, so I'm just going to copy all the y values back down. Well, negative 2 plus 7 is now 5. Negative 1 plus 7 is 6. 0 plus 7 is 7, and 8 and 9 respectively. We can use transformation. Let's plot it out, right? 5 comma 2, so here's 5. Yep, we already have that dot. 6 comma 1. Yep, we already have that dot. 7 comma 0. Check, check, and check. So it doesn't matter how you guys graph this. You should have the same exact graph. Okay, let's go to the next one. Okay, so this is your cubic power. So this is going to give us a degree of 3. And now how do we know the degree of 3? Because the biggest exponent is 3. So degree is 3. And you guys, a is 1 because a is this value in the front. If a is 1 and you have a cubic function, students, it should look like this. That's the parent function. So we know it starts on the bottom, quadrant 3, and then we know it's going to be running, it's going to end up at the top, quadrant 1. So again, if you remember the transformation method, then do that. Start with the parent, y equals x to the third. The parent's always easy, right? We're going to pick negative 2, negative 1, 0, 1, and 2. Negative 2 to a third power, it's an odd power, it's negative 8. Negative 1 to the third is negative 1. You should be able to get these inputs and outputs for the parent extremely easy. Okay, so we have an a value of 1 here, students. So that's not going to stretch or compress or anything. We can get an h value. H value is 2. And a k value of negative 6. And make a transform table. So x plus 2. And then y minus 6. So 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2, and 3 and 4. Now let's go do the y. Negative 8 minus 6 is negative 14. Negative 1 minus 6 is negative 7. 0 minus 6 is going to be negative 6. 1 minus 6 is negative 5. 8 minus 6 is going to be 2. Let's plot this. 0 is going to go all the way to negative 14. I have negative 10, negative 11, negative 12, negative 13, negative 14. We can always extend it a little bit if we want to. And then 1 is going to be negative 7. 2 is going to be negative 6. 3 is negative 5. And then 4, I'm back up here on the top. So it should look very similar to the parent. So here's what we have for our example 3. Now, what happens if you don't remember the transformation method? That's okay. You can start with your h and k point, okay? So your h comma k point, students, is going to be 2 comma negative 6. This is what we call the inflection point, okay? Inflection point. And then that is going to be, okay, well, here's 2, here's negative 6, whoop. Then we're going to pick x values that are some to the right and some to the left. So what we would do it, okay, well, since I started at 2, I would definitely go 1 and going to be 0. That's on the left side, right? And then next I'm going to pick, okay, well, 2 is right in the middle, so I'm going to go pick 3 and then 4. And then this will be to the right side. And then you guys plug it in and you should get the same values, okay? Now let's go to example 4. Now, identifying the degree is super important, which is the highest power. So student, if there's not any power that you can see, it's always 1. So this is a degree of 1. Well, a degree of 1, student, is going to give us a line. Yay! So if it's a line, we can start out with finding the slope right away, which is 2 over 3. We do have an h value right there. An h value is going to give us a negative 5. And a k value right there is going to be negative 4. Well, that is actually, students, that's an h comma k, which is just simply a point. So negative 5 comma negative 4. Oops, negative 4. So we would definitely start with the point negative 5, and then 2, 4. Here's our point. Well, we have the slope, student. Here's the slope. Go up 2, over 3, up 2 over 3, up 2 over 3. And remember, I tend to make a lot more dots than required. Down 2, left 3, down 2, left 3. So here's a straight line. Use your straight edge, guys, meaning a ruler, an ID is even a good idea, a gift card of some sort, anything that will help us make a nice straight line. There you go. Example 5 says h of x equals the quantity of x plus 3 times a quantity of x minus 1. So first, let's state the degrees, okay? So the degree is going to be 2. Well, you want to know how we got 2? We got 2 is because if we were to FOIL this out, so x times x is x squared. X times negative 1 is going to be negative 1x. 3 times x is going to be positive 3x. 3 times negative 1 is going to be minus 3. Well, the degree, if you were to FOIL it out, it would be the highest power, highest exponent, okay? So the x in the front has a degree of 2. So that means your power is 2. Your exponent of that term is 2. Now, because we know the degree is 2, we know that we would have at most 1 turning point, okay? 1 TP, 1 turning point. That will help us out because if we know the a value is in the front, since we don't see a value in the front, students, meaning that it's going to be 1. And that's a positive value. With a degree of 2, a value is 1, we know it is going to be a parabola opening upward. So the easiest for us is it's in factor form. Okay, so this is a factor form. Easiest would be finding the X-intercept. X-intercept, students, is when y goes to 0. So take y, set it go to 0. It's already factored out. So we are going to take each factor and set it equals to 0. And then we want to solve for x. So minus 3. The first X-intercept is at negative 3. We can write negative 3 comma 0. Let's plot that right there. And then we're going to add 1 to this side. So the next X-intercept is going to be 1. So 1 comma 0 is the other X-intercept. Now, easiest for us right now is to find the axis of symmetry. Now, axis of symmetry, students, is going to run straight through the vertex, and it's in the middle. Since we have a dot here on the right side, a dot here on the left side, the middle, smack middle, is going to be an x at equals to negative 1. That will help us plug it in to get the y value for the vertex. Okay, so this is axis of symmetry at x equals to negative 1. And remember, axis of symmetry runs straight through the vertex. We can plug it in. So here we go. So negative 1 plus 3 times negative 1 minus 1. Well, negative 1 plus 3 is 2. Negative 1 and a negative 1 on the next quantity is negative 2. Multiply those together is going to be negative 4. So students, our vertex is going to be negative 1 comma negative 4. Okay, well, let's plot it. Negative 1 we know is on the axis of symmetry, so here's negative 4. This is your vertex. With having the vertex, we can just connect those 3 dots, and that is going to be our parabola opening upward. Now, if you really want to check this graph, another thing that we can do is to find the y-intercept. Okay, so y-intercept is when x is going to equal to 0, and y-intercept, it's pretty easy. We plug it in. Y equals 0 plus 3 times 0 minus 1. Well, 0 plus 3, students, is 3. 0 minus 1 is going to be negative 1. So the y-intercept is currently at negative 3. 0 comma negative 3. Well, let's double check. Okay, it's right there. So you know your graph is correct. All right, that's the end of 2.9. We're done with Unit 2, guys.